Okay, let's do some more quadratic functions. We are on the page 20, section 9.6. Okay, so what are quadratic equations? We have learned in your math152B class. Quadratic equations is what? Second degree polynomials equal 0, right? Then standard form of the second degree is what? Ax squared plus bx plus c equals 0, right? Then quadratic function is a function from x to y, so your y is what? Go through f and get from x. Go through x, go through f, then get to y, right? Then f of x is in the second degree polynomial form this way. So this one we call it what? Quadratic function in standard form, right? But in previous section, we talk about 9.7 before 9.6. In 9.7, we say what? We wrote this way. F of x equals this, right? And when we write this style of the quadratic function, we have what? It has a here, right? We did earlier, a is bigger than 0. If it's positive, it opens up, right? If it's negative, it opens down, right? And also, it tells you what? The vertex is what? H and K, right? And if A is bigger than 0, opens up, less than 0, opens down. Also, if A is bigger than 1, all right, and what? It stretched, right? It stretched thinner or wider because it goes faster, so it's a thinner, right? If it's less than 1 and bigger than 0, half, 1/3, 1/4, things like that, so it stretched what? Slower. The y goes slower, so it stretched what? Wider. So we have two forms for your quadratic functions, right? So one is a standard form, one is a vertex form. So which one gives you more information? Vertex form, because it tells you where the vertex are, and so you can graph in the middle, then you do two sides symmetrically, right? So let's graph some more quadratic functions. That's what you are doing for this class, for the first thing you are learning, right? So then we learned this one before. We have, if it's a linear, we use what? Y equals mx plus b. Slope-intercept form, right? Now we are using for the first degree polynomial function. The second degree, we can write y is your f of x, right? And y is your f of x. And if we write it for second degree, for x squared, is the quadratic function. So we want to have something has square there, then we can know our h and k, the vertex, right? So that's a review what we have done in your 152B class. Okay, so if I have x plus 1, take a square, you FOIL, right? Will be x squared plus 2x plus 1, right? If it's a minus, then here would be minus. If x plus 5 squared, that would be what? X squared, the last one is 25, right? Take a square. The middle one, when you FOIL, then 5 times x and 5 times. So let's just, at least you can see one more time. So that's x squared. Then this one is a 5x. This one is 5x, right? Then this one is 25. So the middle one is what? You double it, becomes 10x, right? So if you FOIL, if you go backwards, and at least then this number, you double it, becomes 10. If you're going back, then this number will be what? Half of your b. Is that right? Leading coefficient is 1, right? Then half of a b here. Then this one will be what? This one will be half of a b. Then this one will be what? You take this number, take a square to get there, right? So if I want to make a complete square, I need to have a third term. I use the first two terms to decide, right? So what do? So we have, if we want to have a complete square, that's my x. Which number will work? It will be half of this. So you need a 3. So when you FOIL out, you double it, will be 6, right? So that, then you need a third term. That would be 9 for it, right? If you look at the second one, m squared minus 2m, you need another number to make a complete square, right? So which number do you need? Half of this. Half of a -2 is -1. Then you need a third term. So you use two terms to find a complete square. Then you use this one, squared. That will be your third term, right? If you have this one, v squared plus 5v plus, if you need another number, what should you have? V plus something squared. So you need half of a 5. Don't use 2.5. Okay, we don't use decimals unless, you know, it's applications for the answers. And usually for the accuracy, we always use fractions, right? So half of 5 is what? 5/2. Then you need a third term to complete it. That will be 25/4, right? So let's see, number 4. Next one. If I have a 3c squared plus 6c, right? If I want to make a complete square, which number I needed to do that? But when we do it, we want to have leading coefficient is 1, but it's 3 here, so we take a 3 out. So c squared plus 2c, right? Then to make a complete square for this one would be what? C plus half of a 2, right? That would be 1. Then you need a third term to complete it. So that's a square. Then we need a square 1 here. Then you carry down the 3, right? In a way, which number do we need to complete the square if it original like this? So you need a 1 here, then you multiply 3 by 3, so this one you need a 3 here to make it a complete square, right? So we need these skills you learned from your 152B class to make what? Quadratic function of vertex form, right? Let's see next 3 examples by using the vertex form with the vertex, right? To graph the quadratic function. So f of x is your y, right? Then let's see what's the difference between these 3. This one is just a basic. This one leading with what? Negative number. This one, you have 2 in front of it, right? So this one opens up, this one opens down. But those are in f of x equals ax squared plus bx plus c, right? In standard form. But we need a vertex form so we know where the vertex is, so we can do our t-table with 2 sides, symmetrical, right? So we have to complete the square first, have a square, something square, right? So we need 2 terms at least, with 2 terms to change it to that, right? So we say what kind of square we should have. And so leading coefficient is 1, so we can just do x. Then the number would be half of a b, would be -2, right? So if it's a -2, what do I need? So let me see. Let me write it this way. Okay, so I have x squared for x. I need a 3rd term. So that was original, right? So I need x squared. So this one is what? -2. So I need a 3rd term to complete it. -2 squared, I need a +4, so I have 3 terms to make the complete square, right? Then, but this +4 is extra, it wasn't in the original, so I need to -4 to balance out, right? So if I do so, then -4 and -9 will be -5 and -4 will be -9. So if this way, do I have a vertex form? Right? And leading coefficient is positive, so it opens up. So this way, I can do my t-table to graph it, right? So let's see, and it opens up. Then my vertex is what? 2 opposite of x, 2 and -9, right? So my t-table, which number I should put in the middle? Opposite 2, right? If you plug in 2 for this one, then y would be -9, right? Then you can put 1 and 0 and, oops, I want to do more here, and 1 and 0 here. Then you plug in 3 minus 1 y squared, so that's -8, and that's -5. Then you plug in, you should get symmetrical, right, for those. So what do I have? I have 0, oh, I do the center first. Okay, center is 2, it's right here. 2 would be, say, -9. 2 and negative 9, 1 and negative 8, 0 and negative 5, right? Then this one will be 3, negative 8, and 4 and negative 5. Oops, I better move over here a little bit. So the graph will look like this. Opens up, right? So we have the parabola this way, symmetrical, and for your exam, next exam, we will ask you a few things. What's your vertex? So what do you think your vertex should be? Vertex should be this guy, right? Because we do have a vertex form as well. And then your line of symmetry, axis of symmetry would be this line. That would be x equals 2, right? We will also ask you, do you have a maxima or minima? So this one on the bottom is what? Minima. Minima is your y value. What's your y value? That's this guy, negative 9, right? We will also ask you, what's your domain and range? Domain, what's your x? Left and right, right? Will be all real numbers. What's your range? From here up, right? So here is what? Negative 9. So negative 9 to infinity, right? We will also ask you, what's your x-intercept and y-intercept. So we need to see if you can see down below. So I can write it here. So for your x-intercept and y-intercept would be, how do you find your x-intercept and y-intercept? Remember, when you do the line, how do you do x-intercept and y-intercept? Right? So you do this. X and y, put x is 0, that would be your y-intercept, right? Y is 0, that would be your x-intercept. So if you do that, and when you plug in x is 0, y is what? Negative 5. So your y-intercept will be, I just want to see if you can see down below. So that would be your y-intercept, right? Then what's your x-intercept? How you are going to find it? So y-intercept is here, x-intercept is somewhere here, right? How do you find it? You plug in y is 0. So it's here. F of x is your y, right? So your y is 0. What do you have? So you have 0 equals x squared minus 4x minus 5, right? All right. Then you factor it. That will be x minus 4, x minus 5, x plus 1. So your x is what? 5 and negative 1. 5 and negative 1. So you have 5, 0 and negative 1, 0. So that would be 5, 0. Oops, this one is not accurate, right? That would be negative 1, 0. Is that right? So here, that would go through like that. That would be 5, 0. So if you do the curve, you wouldn't know where it is. Or you can do the t-table, right? If you do more points, you can see. But to be precise, you better do your what? Solving quadratic equations. That's why you did the 152B class before and this class. Otherwise, you won't be able to solve quadratic equations by factoring to find those intercepts. Right? Okay, so we have this one. Let me see. I try to fit in everything in one place, so we are going to summarize later. Okay, and so for this one, second one, and let's see. All right, so for second one, we wanted to graph it, quadratic function, right? And using property later, but we are using what? Vertex form first. So how do we do vertex form? We have to have x something square. So, but the leading coefficient is 1, so we need to take a -1 out, right? So I'm going to just use the first two variables to find the first two terms to find the third term. So I'm going to use x squared minus 2x this way, and minus 12 was original. So are they the same? Right? I'm just writing differently. Now I wanted to make a square. Oops, I have negative outside, right? I want to make a square. So now I have leading coefficient is 1. So which number I need? -1, right? Half of a b. Then this number would be what? +1. Is that right? Okay, so I do have a complete square. However, this one is extra. Should I -1? Not really. Why? Okay, because +1, but it was negative +1. That means I have extra -1 from the original. So I need to +1 instead. So you need to sort it out with your signs. Okay? Now, let's see. I'm going to, so it's a -11. So do I have a vertex form? Then it opens up or opens down? Opens down because of negative, right? So we are going to graph it. So where is your vertex? That will be 1 and -11, right? So that would be 1 and, say here, 1 and -11. Is that right? So that's the vertex. That's the vertex here. Then you would do your t-table. Which number you put in the middle? This guy, 1, right? 1, 0, then that would be like that. So that's your vertex. Okay, then you have 2 and 3, 0 and -1, 5 points. So I'm going to just put in 0, 2 would be 1, that would be -12, right? 3 would be 2, square 4, -15. Am I right? Do I have typos? Okay, so -12, -15. It should be symmetric. So what do I have? I have 0, -12, 0, -12, right? And 2, -12, and 3, -15, -1, -15, right? So your parabola is here. Okay? Then we also answer those questions. Vertex. Where is the vertex? in the middle one, 1 and negative 11, right? Then what is the line of symmetry? So that would be x equals 1, right? So for this one, we have minimum or maximum. So that's a maximum equals this guy, negative 11, right? And what's your domain and range? Domain left and right for x, negative infinity to infinity. What's your range? How far you can go up and down, all the way down, up to here, right? So that will be negative infinity to negative 11. Is that right? So we also wanted to do xy intercept. You can see what's your x-intercept. Done, right? Then what's your y-intercept? Y-intercept is x is 0, you plug in. Y is what? Negative 12. So that would be your y-intercept. Good? So what are we doing? We are using the vertex form to graph a quadratic function, right? Okay, let's see one more. What happens if leading one is not 1, it's 2? So we want to use 2 terms to find the third term. So what do we do is this way, right? So I have x squared plus 6x, right? Plus 18. So is this original? Same thing, 2x squared plus 12x plus 18. Now this is 2. Then I want to make a complete square by which number? Half of your b, right? That would be 3. If this is 3, your third term needs to be what? 3 squared plus 9. Is that right? Okay. So then 9 is extra, but you multiplied it by 2. Actually, you inject 18 wasn't part of the original, right? So to balance it, you need to minus 18, right? So those cancel out, then you don't have anything here, right? So let's see, what do we have? Opens up, opens down, opens up, right? So where's your vertex? So you do x and y. What do you put in the middle? That's your h, that's your k, right? hk. So that will be, x is opposite. So it's a negative 3 and y will be 0. You plug in. So negative 3 and 0 would be your vertex, right? Then you find the other points. One more would be negative 2, one more negative 1, negative 4, negative 5, right? So negative 2 would be, because a is bigger than 1, so it stretches, right? Thinner, right? So negative 2 is 1 squared times it's 2. That will be 2 squared will be 4 times that would be 8, right? This one will be, let me double check to make sure it should be symmetric. Is that right? Okay, so we also have negative 2 and 2. Okay, negative 2 and 2, negative 1 and 8. Somewhere here. Okay, Then here would be -4 and 2, also -5, -5 and 8. So your parabola opens up, right? So what's your vertex? Vertex right here, right? -3 and 0. And what else we want to know? Okay, line of symmetry will be x equals what? -3, right? Then we wanted to find the minima or maxima. For this one, is a minimum, will be 0. That's y, right? So what's your domain? What's your range? Domain will be left and right, right? Range will be up and down. So that would be from 0 up. 0 up. Okay? Then what's your x-intercept? Right here, right? This one, you have 2 x-intercepts. This one, you have none. This one, you have 1. Okay? Then what's your y-intercept? Y-intercept is somewhere there, right? Somewhere here, right? Where you meet the y-axis. So you plug in x is 0, 0, 0, then y is 18. 0 and 18. Okay? That's how we do the graphs, quadratic functions with the vertex form. Okay? Then what happened if we give you the standard form? You can change to vertex form to do it. Is that right? Okay. However, there is a way to find your vertex directly from the standard form. Okay, so look at your page 21. Let's take a look at those. Okay, so how can we find the vertex directly? Like this one vertex is this one vertex is this, right? And this one vertex is this. So how can we find it directly from the standard form? So on your page 21 and part 2, it says if you have f of x equals x squared plus x plus c, okay, standard form, then your vertex is this. How do you find your vertex? Vertex is x and y, right? Then your x is from your a and b. You can just do that. X equals -b over 2a. Remember your quadratic formula to solve this one equals 0? Then what's your x? X equals -b plus or minus b squared minus 4ac over 2a, right? And look at that. Look at this portion, -b over 2a. That's -b over 2a. So that's your vertex portion. Okay? Then how do you find your y? You just plug in x. Then y is your f of x. And to find y, you can just do that. Okay, so the formula tells you just do it directly from the standard form. You can do it with what? Negative b over 2a to find your vertex. Okay, so if like this, for this one, what's your a? A is 1, b is negative 4, right? So your vertex for x is negative b over 2a. So my x is supposed to be negative b is negative 4 over 2a. So positive 4 divided, so it's 2, right? Then you plug in x, and so your y would be, you plug in original, right? We don't have a vertex form if we use the standard form directly. So you plug in x, 2 square 4 minus 4 times 2, 8. So negative 4 minus 5, negative 9. So your vertex is what? 2 and negative 9. Are they the same? Right? So you can use this later on. We don't need to change it to vertex form anymore. But we used vertex form to let you visualize it. So we can do the symmetrical parabola first. So we can graph it first. Right? So later on, you need to remember this. Directly to do it for the standard form. Then you do your t-table, same as before, 2 and negative 9 in the middle. Then you find your point like before. Then you can graph it. Okay, let's check this one. So this is my standard form. What's my a? My a is negative 1. B is what? 2. So my vertex, by the formula, I should have x equals negative 2 over 2 over a, 2a. So that would be 1. Right? So 1. Then what's your y? Plug in. So y equals, plug in here. 1 squared, negative 1 plus 2 would be 1 minus 12 is negative 11. So your vertex would be what? 1 and negative 11. Are they the same? Right? Then once you find the vertex, then we didn't have to do all the completing the square. Then you can graph the same thing by the t-table, by 1, negative 11. Then you can do all those. You get the same graph. Right? And let's check on this one. And what's your A? For this one is 2. What's your B? 12. Then vertex is what? Negative b over 2a. Right? So it will be what? Negative 3. So you plug in y equals, so you plug in original. Okay, then you get y 0. So your vertex is what? Vertex negative 3, 0. Then you do the graph with t-table. Got idea? So we want you to see it first before we show you the standard form. That's why I switched 9.7 and 9.6. We do the 9.7 first, so you can visualize the quadratic function, the graph, with the vertex form first. Then we do the standard form with the formula to find the vertex. and to graph it so it will be symmetrical. Are we good? All right. So let's see. Let's see if we have more standard form. Okay. How do we find the vertex directly? Okay, we already did 3 of them and compared to previous graph already, right? So let's do some more. If we have f of x equals x squared minus 2x minus 15. So if we ask you what's your vertex, so all you have to do just for the x is negative b over 2a, right? So negative 2, a is 1, right? So that would be 1. Then what's your y? Then you plug in, right? 1 minus 2 minus 15, so minus 16. So your vertex would be negative 1, negative 16. So this one opens up. Okay? So it opens up. Should you have a minimum or maximum? Minimum. So you have a minimum is what? Your y value, negative 16. Good? Okay, next one. If I have f(x) equals negative 2x squared plus x plus 3. So what's your vertex? Right? So you do x is what? Negative b over 2a. So that would be negative 8. 2a is negative 2. So that will be what? 2. Right? Then what's your y? You just plug in. And you can even use calculator. So your vertex is 2, 11. Right? And leading coefficient is negative 2. So it opens up or opens down. So it opens down. So should you have a maximum or minimum? You should have a maximum, which is what? This guy. Right? So that would be your answer for those. Okay? So I keep repeating so you can remember. Hopefully you can remember better, right? So what we have been learning is graphing the quadratic function. This is one of the first things we are learning, okay? So to graph the parabola quadratic function, one is what? With vertex form. One is with standard form. Okay? So this should be easiest thing in this class, and to learn. You should be okay for this. But you do need to practice. Okay, let's see some applications for the quadratic functions, right? You might think you don't care. Probably you do, okay? So what we have been learning is 152A class to graph a straight line. Why should we care about straight line? Because all the lights, the line of sight. So if you want to see something, if there's a mountain, you see it, you cannot see over, right? Same thing, if you have a cell phone, you have to send a signal over, you will not go over, then you have to go through a tower and bounce. Okay, so we need to know how to send a signal, a straight line through your cell phone or whatever. So we need to know how to program a line, right? To graph a line. And then this class, we start to learn curved lines. Why do we care about curved lines? If you threw a ball, you will do like this, right? So you will drop. Why? Gravity, right? So it's all the natural phenomena. So first you learn simple line, then you learn curved line. So it's just a basic phenomena of our environment. So later on in pre-cal, this bend once, you bend twice, you bend 3 times, then you learn all those curves. Okay, so we are learning the parabolas right now. So let's see how we are going to see how they will apply to certain situations. Okay, let's see some examples. On your page 21, all right, it says, if a baseball is projected upward from ground level with an initial velocity of 64 feet per second. So if you hit a baseball, are we talking about baseball? Yes. Okay, with 64 feet per second, then its height in feet is given by this function. Where t is the time in seconds, what is the maximum height reached by the ball? So let's look at this equation function. See what does that mean. All right. So if we do the analysis, you put the t equals 0. What will happen? Plug in. So ht, the height would be 0 feet. 0 foot. Right? Then if t is 1, you plug in, then negative 16. So 64 minus 16 would be 48 feet. Right? So you plug in, and during the next second, you plug in 2. That would be what? 2 square and put in, that would be 64 feet. Right? That's what it means. Then you put the 3, 4, things like that. Okay, so the time t is by the second, so that will be your x, is your t. Okay, equals time. Then your y would be your function, right? H of t, which is your y, right? That is height. So if we do, is this a quadratic function? In standard form, right? Quadratic function is what? F of x equals ax squared plus bx plus c. Right? It's like this. What's your a? Negative 16. What's your b? 64. What's your c? 0. Right? So for this quadratic function, then it opens up or opens down. Started from negative coefficient, so it opens down. So the curve like this, right? 0, 0, 1, 6, 48, 2, 64, things like that. Then we say, what was the question? What is the maximum height? So it opens down, so it has what? Max. Right? Because it opens down. So then the highest point is what? Your vertex. Is that right? Then how do we find the vertex for the standard form? Same as this. We just learned x is what? vertex is xy, right? Then x is what? Negative b over 2a. So b is negative 64, a is negative 16. So that would be what? 2. So your x is 2, then your y you plug in, right? Plug in 2, so it's 64. So your vertex is what? 2 and 64. 2 means what? 2 seconds. Right? That's your x. Then your y is what? That's your t. Then y is what? Your ht. H of t. That's your height. Height is 64 feet. Right? So what's the question? What is the maximum height reached by the ball? It's at the second, right? And after 2 seconds, it reaches the highest point, which is 64 feet. So once you know the parabola and how to find the vertex, if this one is given, right? The calculation is given by the physics, and that's how they calculate things. But right now it's given to you, so you can just use that to find your highest point, right? Okay, let's look at another application. On your page 22, it says, a chain store manager has been told by the main office that daily profit, P, profit, okay, is related to number of clerks working that day. And profit according to your X. How many clerks? According to the equation, because profit is by the X, is this way. Given to you with a what? Quadratic function, right? It says, what is the maximum profit possible? How many clerks are needed to make maximum profit possible? So you look at this function. Leading coefficient is positive or negative? Negative. So for this quadratic function parabola, it opens up or opens down? Opens down. So it has what? Maximum. Right? So how do we find the vertex, the maximum point? You have to find your X and Y, right? X is your how many clerks you are going to have. Then Y is your profit, right? So P of X is your Y. So how do we find the X? By the formula we say is what? Negative B over 2A. So B is 150. A is what? Negative 25. If you do that, it's what? 3. Right? So 3 of what? X is clerks. Then what is your P? Then you plug in your P is your, for 3, right? You plug in, then it's over there, 3 to the square plus 150 times 3 plus 300. Then you will get a 525. What is 525? Not the clerks. It's what? How much money? It's $1, right? So according to this, that's the maximum point. It means what? To reach the reach to the maximum profit of how much money? $525 of, is that daily or I'm just looking at the daily profit, can reach $525 with what? 3 clocks, right? So if you look at the graph, will give you better idea. When x is 0, that means what? $300, right? Here is how many clocks you might have. That's your x. Then y is your profit, right? If you use 0%, that means you might work yourself and you can make a $300 profit. If you use 1%, you might make more, 2 make more, 3 is supposed to reach the highest point, 525. Then when you use more people, you have to pay more insurance and expense. You may not have that much business, right? So your curve parabola opens down, looks like this. That's what it means. So you can see your function, how it works. By graphing it, then relay. You need to relay what is your x you are using and to reach your y, the profit, this way. Okay? Got idea? So the maximum profit is $525. How many people you need to employ the clocks? With 3. If it's the function is given, you can do it with your formula. X is what? Negative b over 2a to find your vertex. Got idea? That's how we use what? Quadratic functions with property of the vertex point. Okay? So that would be your section 9.6.